Hello, this is Unit 2 Measurement, Lesson 3, Video 1. In this video, we're going to look at the definitions of accuracy and precision. And for accuracy, we're going to look at a way that we can calculate how accurate a measurement is. So accuracy is defined as the agreement of a value to an accepted or given value. So we use this all the time when we grade things. So we're comparing your answer to what is the correct answer. If you are accurate, you get it all right. If you're not accurate, it does not match. So for this, we're going to calculate something called percent error. And the formula is given here. It is the experimental minus the accepted all over the accepted times 100. So the experimental is what you measure. The accepted value is what is given, or the correct value. And with this, we could get positive or negative values for percent error. All positive means is your experimental is greater than the accepted, which means that what you measure is higher. So you got above. So your measurement is higher than accepted or than expected. Negative is the opposite. Experimental is less than accepted. So that means that your measurement is lower than expected. So we would use this as follows. A person measures the volume of a 400 milliliter beaker as 405 milliliters. What is the percent error? So the first thing you have to figure out is which measurement is experimental and which is accepted. So with this, a person measures the volume as 405. So this is our experimental, and it should be 400. So we just use this formula. Experimental, 405, minus the accepted, 400, all over the accepted, times 100. So we do 405 minus 400, it equals, divide by 400 equals, and then multiply by 100. Everything here, we're going to have the same number of significant figures. So if we get 1.25%, really our answer, I'm going to put a decimal point right after this so that we have three significant figures. So we have three significant figures all around. So that gives us a 1.25% error. It is positive. So that positive value means that our measurement is bigger than what we should get. So there is a worksheet in this folder that you can do based on this, and we're going to do a little lab activity based on this too. Precision, on the other hand, is a degree of agreement among measurements. So basically, we're looking at groups of measurements. And how close are the values to one another? So we use this based on groups of measurements, and you're given like a plus or minus and a range of values that the majority of the values fall in. So you might be given a measurement like this, 5.00 centimeters plus or minus 0.50 centimeters. So that means that most of the measurements are going to be between 4.5 and 5.5 centimeters. So that's a grouping measurement. And the more markings there are on an instrument, the more precise the measurements are going to be. So this has a correlation or a similarity with the more markings on an instrument, the more precise the measurements. Those of you that hunt or maybe participate in a sport that relies on any kind of targets like a basketball hoop, your level of precision is, especially when you're maybe shooting in a rifle, is grouping all those measurements together. So we can look at a game of darts to explain precision accuracy. So if you are precise, that means that your measurements are all grouped together, but it might not be accurate. If you're playing darts, accuracy is going to be right in the middle. So getting each measurement right in the middle, you would be accurate. Remember, accuracy can only have one measurement. Precision is a group. So if you were precision, your grouping of darts might all hit in the same area, but it's not accurate. If you have precision and accuracy together, that means that all of your darts are going to be grouped in the middle in the bullseye. And if you play darts like me, you might be all over the place. You're neither precise nor accurate, and maybe you hit the wall over here somewhere. Go ahead and work on the worksheet on percent error.